Hello everybody, my name is Elnor and today I'll be presenting about Bernoulli experiment. So let's move on. Table of contents. So we will start from introduction and theory, objectives and methodology, experimental setup, results and discussion and conclusion. So as for introduction and theory, energy presents in the form of pressure, velocity and elevation in fluids with no energy exchange due to viscous dissipation, heat transfer or shaft work. The relationship among these three forms of energy was first stated by Daniel Bernoulli, and this is the law of the Bernoulli in the base. So it is based upon the conservation of energy principle. And in this experiment today we will check the validity of Bernoulli's equation. So Bernoulli's theorem provides a mathematical means to understanding mechanics of fluid. It has a lot of real-world applications ranging from aerodynamics of an airplane, calculating wind load on buildings, designing water supplies, sewer networks, measuring flow using devices such as weirs, partial fluence, venturimeters, and a lot of stuff that there is no end to it. So as you can see, it's very useful in terms of industry and agriculture. So, what is the formula for Bernoulli's equation? It can be given in three or four forms, but most generally, it is the one that P over rho g plus V square over 2g over plus h. H is height, V is velocity, and P is pressure, rho is the density of the fluid. So, objectives and methodology. So what is our objectives? First one is to use the venturimeter apparatus to study the effect area of the flow, velocity and pressure, to use the Bernoulli's equation to compare the behavioral and ideal real world fluid, and investigate the validity of Bernoulli equation when it is applied to a steady flow. So what is the procedures then? First, we place the venturimeter on a horizontal surface. Second, we attach the apparatus with power supply. Third, we open all the air blade valves. Third, on the power supply to run the pump and adjust the flow rate volume control. Uh, 5, we place the stop plug in basin. Then we take note of the time. And 7, we remove the stop plug to drain all the water. At 8, we place the dynamic pressure probe with the static pressure port, and then we put the dynamic pressure probe but with different and next static pressure probe, which means just changing it. And we repeat the steps to measure the data from all the manometer probes, so we just keep changing the static pressure port, and we turn off the pump and set off the power supply, and that's it. So what are experimental setup? So there is venturimeter, supply hose, and measuring tank. As you can see, venturimeter is, we said before, it is an application of Bernoulli's law, right? So after getting some calculations and results from the internet, let's analyze these results. You can, I believe, read it. So these blue ones are theoretical values that we made them a graph, and red ones are experimental values. So in the base, you can see that theoretical values differ a bit from the experimental values, and actually this is one of the main reasons that we are doing this experiment. So let's come to the results and discussion. So from the calculation, it's very clear that with decrease of area of the flow, velocity increase and the pressure decrease. As shown in the graph, all three tests that decrease in the area of flow decrease the height of the water in manometer column. Means they are directly proportional to each other. It means like one increase, the other one increase. One decrease, the other one decrease as well. So the difference in the theoretical and measured value, it can be said that the water is not an ideal fluid. Height of the water in the final column was not equal to the initial values, which show that there are friction losses, which also again restate that it is not an ideal fluid, because in ideal fluid there is no friction losses. So this type of information is very useful in the case of nozzles, jets, and diffusers. So what can we conclude from here? The objective of this experiment was to discuss the behavior of ideal and real fluid. On the basis of the test result, it can be concluded that the experiment was successful because there is difference between measured and theoretical values. And this is because of the friction losses in the real fluid. Ideal fluid does not have friction losses. From the experiment, it can be concluded that with decrease in the area of flow, There is an increase in velocity and decrease in flow pressure of the fluid. So one of them is uh, directly proportional, the other one is negatively proportional. So that's it for the Bernoulli's experiment. Thank you for your time and have a good day.